So we have our test today. Let me remind you about that. We'll post it at 1 p.m. on Canvas. Make sure you read the instructions right at the beginning of the test. And remember that you're supposed to do the work on your own. You can consult your notes and the book, but you're not supposed to get outside help, or you're not supposed to share your solutions either, all right? It's very important. I didn't mention it last time, but if we have the same file uploaded by two different people, both of them will get a grade of 0. So it's already, you have already a lot of flexibility here. You have 24 hours to do the test, so don't put me in the situation of having to fail someone because of not following the rules. Okay, so what we're gonna be doing today is reviewing for our exam. So if you have any questions, make sure you ask them today. If there aren't any questions, or even if there are a few of them, we'll work on some of the review questions from the sample final exam, and that's a good thermometer and a good way to prepare for our upcoming exam. Okay, so let's open it up. Let me see. Yeah, okay. So anyone has a specific question, a particular question, a problem that you would like to work on? Our exam, let me remind you, is chapters 11 and 12, right, for the sections we covered. I mean, there were a few sections that we didn't cover. So we started with Taylor polynomials. That was section 11.1, I believe. And then we did the entire chapter 11. That's till 11.4, working with Taylor series. And then we had 3 sections of chapter 12, 12.1, 12.2, and 12.3. Parametric equations, polar graphs, and calculus on polar graphs. All right?
Professor.
Okay, so questions. Are there any questions?
Professor?
Yes.
We do number 21C when we get to it. It doesn't have to be first.
Sure.
Study guide.
21C. Let me make a little note here. 21C. Yeah, so we remember to at least do that one. Absolutely. Anyone else? Can you use the Zoom videos to help you for the test? Yes, Alexandro asked. Absolutely. That's fair game. It's like reading your notes. Okay, so last time we worked on 18. We should, so 21C is the one that, was it Michael?
It was Ben.
Okay, so let's go in order. So first, let's do one of these from 19. So from problem 19, we have a few of them for us to try. So some of them are about radius of convergence. Some of them are about finding the interval of convergence. So let's pick something that has the, we can actually do for both. So let's pick something like, what would be a good one to try here? How about 19A, the second A. So let's try that one. So that's find the interval of convergence. And the problem is the series from 1 to infinity, x minus 2 to the k divided by 3 to the power k root k. All right, so let's try that one. Let me switch to the page. Okay, so this problem right over here. Now remember, to find the radius of convergence, the first tool is the ratio test. So ratio test is the way to go. And so we do the limit of the k plus 1 term divided by the k term, the absolute value of that. So that will be x minus 2 to the power k plus 1 divided by 3 to the power k plus 1 square root of k plus 1 times, and then I'm just going to flip it here. So x minus 2 to the k, 3 to the k, root k. That's the limit you want to do. Then if things are positive, take them out of the absolute value bar and then simplify everything else. So here we can simplify the k plus 1. This cancels with the kth exponent. Here the 3 to the k cancels with the k exponent. And the only thing that could be negative or positive here is the x minus 2. So I will leave that there. So it's x minus 2, the only thing that survives. And then we have root k at 3 and a root k plus 1. Okay? Next, to do this limit, you want to take the things that don't have to do with k outside. So take the x minus 2 and combine everything else. Take the x minus 2 and the 3. And then all that remains is 1 big square root of k over k plus 1. And now this limit we can do, right? Is the inside the square root. This is like one polynomial divided by another. And both of them are degree 1. So the limit when k goes to infinity of this is 1, right? So what we get is x minus 2 divided by 3, okay? And then if this is less than 1, then the thing will be convergent. So you wanted it convergent, so less than 1, convergent. And then you make it x minus 2, you multiply by 3, and now it's less than 3. And this is how you figure out the radius of convergence. So r equals 3 is the radius of convergence. And now you also know more what is your interval. The only thing you need to do is check the endpoints. So the way to check what the interval is the center is 2. You go 3 units this way, that's 5. And you go 3 units this way, and that's 1, 0, negative 1, right? So our interval is from negative 1 to 5. And the only thing left for us to do is check the endpoints, right? So let's do that quickly. Check the endpoints. First try negative 1. I mean, we need to do both of them, so it doesn't matter in which order you do them. So plug negative 1 back into the original series right here. So it becomes negative 1 minus 2 to the power k, 3 to the k, root k. And this is negative 3 to the power k, 3 to the k, root k. You can separate that negative 3 as negative 1 times 3. So it's negative 1 to the k, 3 to the k, 3 to the k, root k. And that's useful because it lets you cancel these 3 to the k, right? And then your new series is negative 1 to the k over root k. And now that's the one we need to figure out if it's convergent or divergent, right? And what is it? And which test should we use? So the alternating, that's right. The alternating, Gisela, thank you. So indeed, so we check the limit of 1 over root k. That's 0. Good. And is it true that 1 over root k plus 1 is less than 1 over root k? And that's also true because the square root of a bigger number is bigger than, the square root is increasing. So here the square root of k is smaller than the square root of k plus 1. So converges by alternating series test. Good. Let's check the other endpoint. So this was negative 1. Now let's check the other one, which was 5. We plug it, plug 5, and now we get 5 minus 2 to the power k, 3 to the k root k, and that's 3 to the k, 3 to the k root k. These guys go away. So this is 1 over root k. What do we know about this one? Give you a clue. The same as 1 over k to the 1/2.
It diverges.
It diverges, and by which test? P series. That's correct. Again, Gisela, thank you. So P series, so P equals 1/2 is less than 1. So diverges by P series test, because 1/2 is less than 1. So altogether, then the interval of convergence is -1 worked, -1 worked, 5 did not work. So it's -1 is included and 5 is not included. All right? Is that clear? So that's just a sample of the way you should do any of these problems. So they're all a bit different, so get practice with them. But that is a summary of any of these problems in 19, right? For all of these, even though the first 3 only say radius of convergence. So if it only says radius of convergence, you don't need to check the endpoints, right? Then you're done with the first part of what we did. But if you want to do the interval of convergence, then you do need to check the endpoints. Okay? All right, let's move it along. Then for this one, 20, it says know the power series of 1 over 1 minus x, e to the x, cosine x, and sine x, etc. It says find a power series expansion of f of x from known series, at least 3 non-zero terms. All right. So to do these ones, you can do them the easy way or the hard way. The hard way would be to try to figure out the Taylor series, right? And that's a hard way because it involves taking the first derivative, the second, the third, the fourth, the fifth, the sixth, all of them, and figure out a pattern, right? So it's always better if you actually start from one that you already know. And we talked about this, and it even says over here, what are the ones you should know quite well? So you should know 1 over 1 minus x, e to the x, cosine x, and sine x. Those you should definitely have a handy, right? Know as a good reference. So I'll write them here. So let's figure those out first, and then we'll take a look at some of these problems. So let's go back to the page, and we want to look at this series. So the first, this one, 1 over 1 minus x, that's one of the most important ones. That's just x to the k. In other words, 1 plus x squared plus x cubed, etc. And it works from -1 to 1. Very important. Next one that is really important is e to the x. That's x to the k over k factorial. Center at 0. So 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4 over 4 factorial, etc. And this works for any x. That's nice. And then sine and cosine. So sine has the odd numbers. It alternates. And that's 2k plus 1 factorial is how 2k plus 1 is how we know we go over the odd numbers. So this starts at with x, then it's x cubed over 3 factorial, x to the 5 over 5 factorial, x to the 7 over 7 factorial, x to the 9 over 9 factorial, etc.
Professor,
Yes.
I have a question.
Yeah.
Can the alternating sign for sine x can be -1 to the power of just k?
If you put it -1, yes, actually it is. Should
Yeah.
be.
Okay.
Yeah. Should start with positive, right?
Yeah, that's what I thought. Yeah, exactly. Okay.
Yes. Thank you.
Of course, of course.
Yeah. And then cosine is similar, but with the odd numbers. So negative 1 to the k, x to the 2k, over 2k factorial. So that starts with 1, square over 2 factorial, x to the 4 over 4 factorial, etc.
Wait, sorry, I have another question. So if it starts off as negative for the alternating sign, that's when we would put k plus 1, correct?
Yes. Yeah.
Okay.
Mhm.
Okay.
Okay. So these are your basic ones that you want to work to get other ones. So now let's take a look at some of the problems and how we could get quickly some of these. For example, say C, cosine of root x. How do we do cosine of root x? Well, that's easy, right? All we need to do is plug root x in place of x in the one we already have. Yes. So let me go back to the page. So we had this one for cosine. So then instead of x, or imagine that it says y. So let me change it to y. That's probably the better way to do it. So you make this y. Then all of these numbers are y's. And then if you want to do root x, what we're doing is we're letting y be root x. Yes, so it's just a matter of plugging root x in here. So you put root x to the power 2k. And the nice thing is that the root x to the second power is just x. So this becomes negative 1 to the k, x to the k over 2k factorial. So, or you can plug here directly. So it would be 1 minus x over 2 factorial plus x squared over 4 factorial minus x cubed over 6 factorial, etc. Easy, right? I mean, it didn't require a lot of work. It's just like a way of substituting one to get the other one, right? Let's go back to another one here, see what we can see. For example, for E, if we wanted E, for E, all we need to do is take the one for sine, plug x squared, and then once we get the answer, multiply everything by x, right? Easy peasy as well. So that's an easy one to do as well. Maybe let's try something a bit more challenging. How about B? Let's try B. So for B, we want 2 over 3 minus x. So this should, so what is the one we should be using? We should be using 1 over 1 minus y, right? This one, which is just 1 plus y squared plus y cubed, etc. So how can we make this one look like that one? That's the important thing, right? And here's the thing, though. The thing is, we don't have 1. So the 1 is very important, and we don't have it. So because we don't have it, we need to make it happen. How do you make it happen? Well, let's take, we also need a 1 on top. So we may as well take the 2 and the 3 out. So this will be, now this is 1, perfect. And then 3 times, it should be 1. And then over here will be x over 3, right? Do you realize how I factor here? Easy, right? And then now this looks like that. Now these two look alike. What is the y I should use? Well, x over 3, right? So if I use y equals x over 3, I get what I want. It will be x over 3 to the power k, from 0 to infinity. And that's it. That's the answer. You can expand it if you want, or you can leave it like that. Doesn't really matter. So if you put it all together, it will be this. It will be 2x to the k over 3 to the k plus 1. Right? And more importantly, right, where is this valid? Right? What would be to do the interval of convergence, or you could do it the hard way, you know, do the ratio test and figure it out. Or you could remember where this one is valid. this one is valid between -1 and 1. So when you do this substitution, now the new one, so the new one will be valid between -1 and 1, but for x over 3. So then all I need to do is multiply by 3, and then it tells me that the new one is valid between -3 and 3. All right? Is that clear? Let's go back to the list of problems. So that was kind of like B. A is in a similar way. So here the only one that is really challenging would be F. But well, first F, we did it in class already. So it's one that you can, I mean, it's also in our list of important ones to know. But in case you had forgotten where it came from, the way to get F is by integrating 1 over 1 plus x, right? So let me quickly do it so you can see that it's not that big of a deal regardless. So first, we want to figure out what would be 1 over 1 plus x. And that's easy. So from here to here, we just use y is negative x. So this one will be 1 minus x plus x squared minus x cubed plus x to the 4th, etc. So it's the alternating one, right? And then to get ln, we integrate. Because we know this is ln of 1 plus x. And all we need to do is integrate this. So it's the integral of 1, that's x. The integral of x, that's x squared over 2. The integral of x squared, that's x cubed over 3. Minus x to the 4 over 4 plus x to the 5 over 5 minus etc. So in sigma notation is -1 to the, let's see, so it's going to be over k. So now we want it starting at 1, so it will be k plus 1, right? So the first one is positive. And that's it. Okay. Questions? Okay, let's go back to the list of problems. So now we're in 21. And now this is kind of like backwards. Now we give you the series and we ask you to see if you can figure out what is the original function that we started with, right? And some of these are easier than others. So Michael asked about was it the last one?
Yeah.
Okay. So let's see. So we have f of x equals e to the negative kx from 1 to infinity. All right. So let me go back to the page. So the way to do these problems is like backtrack, figure it out, like, you know, a detective working backwards, right, from the end result. So this is the end result. So it doesn't quite look like a regular power series, right? A regular power series looks like something to the power, to powers that keep increasing, like x squared, x cubed, x to the 4th, and so on. And this is different in that sense. So you first need to make it look like something that grows with powers. And the way to do it is if you write it like this, e to the negative x to the power k, right? That's the same. But now it kind of looks like something that goes 1 to the power 1 to the power 2 to the power 3 to the power 4, etc. Right? In fact, if I remove another e to the negative x, and as you see in a moment why I'm doing this, so I take an e to the negative x out of the sum, so that now is e to the negative x to the power k minus 1. And I am doing this because this one starts at 1. And now, because I made it k minus 1, so now it starts at 0, just like I wanted. So look what I have. This is e to the negative x times, if you do j substitution, where j is k minus 1, now this is from j equals 0 to infinity, e to the negative x to the j. right? Now, Michael, this should remind you of this one. What is this one? Y to the j, from 0 to infinity. What is this equal to? Is the geometric series. We used it before. In fact,
Is it 1 over 1 minus y?
yeah, it's this one, right? It's this one over here. So yes, so this is exactly 1 over 1 minus y. So now how can you make this one look like that one? What y should you use?
E to the negative x.
Correct. And then this becomes e to the negative x times 1 over 1 minus e to the negative x. So the answer is e to the negative x over 1 minus e to the negative x. And that's it, right? Now it only works in a little neighborhood, so let's find out where this works. This works over here, works when -1 is less than 1, where y is between -1 and 1. So now this one is going to work where e to the negative x is between -1 and 1. And, well, e to the something is positive, so this inequality is worthless, doesn't tell me anything. The important inequality is this. So I can take now ln, and this tells me that -x is less than ln1, right? And ln1 is 0. So this tells me that x has to be greater than 0, right? So this is where this one works. So this is equal to that series that we started with when x is greater than 0. Okay. All right, now let's take a look at the other ones on that same one. So the other ones, see, this one also looks kind of like geometric one, right? If you isolate the to the power k, looks like x minus 1 over 2 to the k. So that means if you make y x minus 1 over 2, you'll get it. This one as well, if you isolate the something to the k, then it looks like negative x squared. So this looks like the geometric series when you make y equals negative x squared. All right, you see, I just took a quick look and I already know how to do this too. There's no need for me to keep going there. All right, let's move it along, otherwise we won't get to see any of the other types of problems. So number 22 is about Taylor series. So for Taylor series in this kind, you can either use the, so for some of these, you do need to do it with the derivatives because the centers are no longer 0, right? Or there are functions that we're not as familiar with. The good thing is that you don't need to do the entire thing. It only says the first 4 non-zero terms. So it's not the Taylor series, if you think about it. It's just a Taylor polynomial that you're asked to do. You only need to do the first 4 terms. So we can try one of these if you want. I mean, this would be like B is like the P series, the binomial series, I mean. This one, 2 to the negative x. I don't know. They're all. I mean, let's try A. Well, A is centered at 0. Let's try something not centered at 0. How about C? So 22C. So we need f of x equals sine 2x, and the center is pi over 4. All right. Let's change to the page. Good. So what is the Taylor series formula? Is the kth derivative evaluated at a divided by k factorial x minus a to the k. All right, so this is what we need. That's the recipe. Now let's look for the ingredients, right? What are our ingredients? Well, we need the derivatives of different orders, and we need to plot them at pi over 4. So let's make a list over here. So here's k. And over here we're gonna do the kth derivative. And then we're gonna plug pi over 4. Starting with the original function, that's sine 2x. And when you plug pi over 4, you get sine of pi over 2, which is 1. We have 1, right? Remember, we don't need to do all of them. We only need to do 4 terms. I'll make things easier, right? First derivative. The derivative of sine is cosine. And the derivative of 2x is 2. And then we plug pi over 4. So it's 2 cosine of pi over 2. And cosine of 90 degrees is 0. All right, so that doesn't count because it said the first 4 non-zero terms. So that one is not going to count, right? Because it's 0. So we got to keep going. Second derivative. The derivative of cosine is negative sine. And this 2 will multiply that 2, so it will be negative 4 sine of 2x. We plug 2, and we plug pi over 4, and it's going to be negative 4 sine pi over 2. So that's negative 4, right? We have 2 already, right? Let's keep going. Third derivative. 2 will multiply here, so it will be, and the derivative of sine is cosine, so it will be negative 8 cosine 2x, and that's going to be 0 because cosine of pi over 2 is 0. So that one doesn't count either. For derivative, the 2 comes down, it will be negative 16. The derivative of cosine is negative sine, so it will be positive 16 sine 2x. And when we plug pi over 4, it will be 16 sine pi over 2. So that's 16. So 1, 2, 3. We need one more. The fifth one will not work. We already know it. It will be 32 cosine 2x. And that's 0. But the sixth one will work. So the sixth one will be the derivative of cosine is negative sine. So it will be negative 64 sine 2x. So this will be negative 64. All right? Perfect. So that's it. We have our numbers. And so those are our ingredients. So let's just put them now into the pot and present the dish, right? So we have the first one when it's 1 for 0 factorial. So it'll be simply 1. Well, then the next one is negative, and it's with the second. So it's negative 4 over 2 factorial x minus pi over 4 to the second. The next one is 16, and it goes with 4. So it's 4 factorial x minus pi over 4 to the power 4th. And then the last one is 64. It goes with 6. And it's x minus pi over 4 to the power 6. Right? Now, this one is not that bad. We actually sort of see the pattern, right? So the odd ones are zeros, and the other ones are increasing by a factor of 4. And they alternate signs, right? You go 4, 16, 64. The next one is going to be times 4. It would be 256, and so on. Okay? All right? So that's how you do. I would consider these problems easy because they are all, you don't need to think, right? You just need to, you be patient, calculate the derivatives carefully and plug them in. All right, number 23. This is about figuring out a power series. I mean, estimating, calculating this integral as a power series, all right? And this is important because many of these integrals you cannot do, but you can do them if you think of them as power series. So let me try one of these. For example, I'll try part A. Equally easy, part A or part B. Or part B, I really don't mind either way. I think part B, let me see, is that an even function? I think part B is extremely easy because this, I believe this, oh no, it's an even function. Okay, now, okay, let's do part B if you want. I really don't see a difference. So what is So for part B, we want to integrate this from -1 to 1 cosine of x to the 4th. Now, maybe you think this is an easy integral and then you can do it in a different way. And I can tell you right away that no, this is one of those integrals that if you try to do directly, you're gonna hit your head against the wall because it's one of those that cannot be written in terms of elementary functions. So the idea is to go around that using the series expansion of cosine. So let's write down the cosine. We're using y. The cosine of y, like we said before, is this one. -1 to the k, y to the 2k over 2k factorial. Right? We wrote this one before. And here, we don't want y, we want x to the 4th. So the idea is to set y to be x to the 4th. And then this becomes -1 to the k, x to the 4th to the power 2k over 2k factorial. Or in other words, x to the power 8k, or 2k factorial. Okay, fantastic. So that's when y is x to the 4th. So now we just put this in the integral. So if we want to integrate from -1 to 1 cosine of x to the 4th, all we need to do is integrate from -1 to 1 this series. Now it looks complicated, but it's just because we're carrying around a bunch of stuff, but it's not complicated at all. You'll see in a moment. We need to integrate this, and we can integrate by doing things term by term. So that means we can add up all of these. The -1 to the k doesn't have to do with the integral. The 2k factorial doesn't have to do anything with the integral. So all we need to integrate is x to the 8k from -1 to 1, right? This is the only thing we need to do, this little integral. And that's easy, right? It's just add 1 to the exponent and divide by that new exponent. So here we go. The answer will be -1 to the k divided by 2k factorial. And like we said, this is x to the 8k plus 1 divided by 8k plus 1. And we're evaluating it from -1 to 1. Okay, let's do it here. We plug 1, so that's 1 over 8k plus 1 minus, and then you plug -1, it's -1 to the 8k plus 1 over 8k plus 1. And -1, because this is an odd exponent, this will be -1. Negative times negative, it would be positive. So here's the answer. The answer is -1 to the k, 2, because there will be 1 plus 1, divided by 2k factorial times 8k plus 1. That's it. That's the answer to this integral. I mean, maybe you don't like it as an answer because it's a series, but it's an answer. And it's actually a good answer because it's a series you can approximate to a lot of the precision if you simply plug the first few terms. So you can plug from 0, 1, 2, 3, 4, the first 4 terms, and that would already be an awesome approximation, right? So if you want to approximate it, you can use the first few terms. So if you use the 0 term, this would be 2, you start with 2. And the 1 term, it would be -2 over 2 factorial, that's 2, 8, so I'm using 1, k equals 1, and times 9. Plus, next term, if when k is 2, it will be 2 on top, 2 times 2, that's 4 factorial, 24, and times 17. Minus, let me do one more, and this would be 6 factorial. 6 factorial is let's see, 720 times 8 times 3, 24 plus 1, 25, etc. Right? So this is already quite a good approximation. It will probably be good within the thousands, but that's not what the question is asking. So we won't have any questions about how accurate is the approximation. It's just about finding the answer to this integral. Well, in this case, it says using two non-zero terms. So here we only had to do the first two. But actually, it is possible that you are asked to do the entire answer to this integral as a series, right? Either for this one or that one or anything similar to those. Okay. Any questions so far, all the way to 23? Because now we're going to change gears, right? So that finishes up the power series stuff, chapter 11, and then we move on to chapter 12. So chapter 12 is about parametric equations. So for chapter 12, we have first 24 is about eliminating the parameter. So that's a way of going from parametric equations to regular equations. Problem 25 is about figuring out the tangent line. And then we have polar graphs. So let's first figure out one of these, like, for instance, how can we eliminate the parameter? So to eliminate the parameter, what you want to do is solve for t if you can. And if you cannot, use a nice identity that relates the parameters. For example, for part C and D, for these ones over here, what you want to do is use the fact that sine squared plus cosine squared equals 1, right? So let me do 24C, for example. So what I want to use is that sine squared plus cosine squared equals 1. And what is sine squared? Well, if I solve for sine, that's x over 3. And what is cosine squared? If I solve for cosine, that would be y over 3, right? Let's do it here. Cosine t will be y minus 2, everything divided by 3. So that's what I put here. And that's it, right? We got it. So this is 1 equals x squared over 9 plus y minus 2 squared over 9. And if you multiply by 9, this gives you this. And if you remember your analytic geometry classes, this is the equation of a circle of center 0, 2 and radius 3. Circle of radius 3 centered at 0, 2. Okay, so that's what makes it work. And the same thing works for this one, right? So for D, what you want to do is, again, sine squared plus cosine squared. So cosine squared will be x squared. So that means y plus x squared equals 1. That's it. I did it, right? For these A and B, you want to solve for t. And that's easy because you can solve for t here in A. You can solve for t in the first equation and plug in the second. And for part B, you can solve for e to the t on the first and plug in the second. So they're all straightforward. So let's move it along instead to things a bit more challenging, more interesting. Let's figure out the tangent line. So how do you find the tangent line? For instance, let's do part B. So 25B. Okay. So how do you find the slope? That's the first question, right? How do we find the slope? Well, the slope is dy dx when t equals 1. And that one you can do by doing dy dt divided by dx dt. That's what you need to remember. So you need to do the derivative of y with respect to t. What is the derivative of arctangent? That's 1 over 1 plus t squared. the derivative of ln t, that's 1 over t, and then plug 1. So that will be 1 over 2 divided by 1 over 1. So the answer is 1/2. Right, so that's my slope. And that's essentially the problem, because all I need now is a point, right? So what is the point? So when t equals 1, x equals ln of 1, which is 0, and y equals arctangent of 1, which is what angle has tangent 1?
Pi over 4.
Yes, pi over 4. And then that's it, right? What's the equation? Is y minus pi over 4 equals the slope, which is 1/2, times x minus 0. So all of these problems are easy. So the only important thing is to figure out the slope, right? And you figure out the slope by remembering that dy dx is the same as the derivative of y with respect to t divided by the derivative of x with respect to t. Good. Moving it along. So I'm not that concerned if we don't get to see the last ones, because that's the last part of the material that we went through. So we figured out, we worked a bunch of problems about areas last class. So let's see about this one. So 26, we have a few problems that are about the polar equation from converting to polar to Cartesian. That's 26. And 27 is about also tangent lines or arc length. All right, so let me start with 20. Let's go in order, actually. So how do we change from polar to rectangular, right? And so let's see which one looks the hardest here. Probably B, right? How do we change to Cartesian? So this is 26B. And we have r equals 3 over 2 cosine theta plus sine theta. Okay, and the idea is to remember to use what we know, right? What is it that we know? We know that x is r cosine theta and y is r sine theta. So out of these, you want to get these involved. You want to get r cosine theta and r sine theta. And you don't have cosine theta, and you only have cosine and sine. You don't have the r. So because you don't have it, let's put it in, right? Let's multiply it so that we actually get it. So how do we do that? Well, we can multiply by r top and bottom. Right? So this becomes 3r on the top, and in the bottom, 2r cosine theta plus r sine theta. And that's great, because now we can change this to x and y. And the r is going to cancel, actually, so we were lucky, right? If you divide them by r, what you get is 1 equals 3 over 2r cosine theta plus r sine theta. So this is 3 over 2x plus y. And then that's it. You can multiply that by that, multiply by 2x plus y. So you get 2x plus y equals 3. And so this, believe it or not, is the equation of a line. It looks really complicated in polar form, but it's just a line. Okay? So that's the way to do it. As you can see, not much to it. Similar to this one, right? Let's try this one. Let's try A since we're at it. So A is r equals 6 sine theta. The same trick applies. So sine theta is by itself. It doesn't have the r, so let's multiply by r. So let's do r squared equals 6r sine theta. And that's good, because now this is r sine theta is y. So this is 6y. Now the problem is that now r squared is by itself. But then we can use the other one that we should remember. So what is r squared? Well, r squared is x squared plus y squared, right? That's how we get r. So we can replace r squared by x squared plus y squared. And that's it. That's our equation, right? And you can, if you want, you can complete the square. So this is x squared minus 6, x squared plus y squared minus 6y equals 0. Add 9 to both sides and complete the square. And now you know that this is a circle centered at 0,3 of radius 3. Circle centered at 0,3 with radius 3. Right? Okay. We have about 10 minutes. So let's take a look at the other questions. So these are tangent line in polar form and arc length in polar form. So for those, you need to remember your corresponding formulas. So the corresponding formulas, so for arc length is the one we did yesterday, and that's the integral from alpha to beta of f of theta squared plus f prime squared. You need that formula. And for the derivative, so the slope, which is dy dx, that is given by, let me switch to the page so you can see what I'm writing. So this is the one for arc length, and the one for the derivative is, I always forget about it, but so then, well, that's no problem. I can always figure it out again. So remember that x is r cosine theta, which is f of theta cosine theta, and y is r sine theta, which is f of theta sine theta. So when I do these derivatives, I get the derivative of y, that's f prime sine plus f cosine, and the one in the bottom will have cosine here and then a minus and a sine here, right? So this is the formula you should remember, right? Either this or that, depending on the problem. So now let's take a look at the problems. For instance, let's do this one. It says, find the tangent line of, so 27a. Find the tangent line to r equals e to the 3 theta at theta equals 0. All right, let's do it. So we need to use this formula to figure out the slope. So it's the derivative of e to the 3 theta, that's 3e to the 3 theta sine theta plus e to the 3 theta times cosine theta divided by the derivative, that's 3e to the 3 theta times cosine minus the function times sine. And this simplifies a lot because you can cancel the e to the 3 theta, right? So you can factor an e to the 3 theta on the top and an e to the 3 theta on the bottom, and then cancel it, right? So that's it. So now the slope at 0, so the slope when theta equals 0, when you plug 0, you get 3 sine 0 plus cosine 0 divided by 3 cosine 0.
Professor, can you go down a little for the...
Sure.
I can see.
Minus sine 0.
Yeah, thank you.
And sine 0 is 0, cosine 0 is 1, Cosine 0 is 1, so this is 3 minus 0, so the slope is 1/3, right? So that's half of, that's a hard part of the problem. So that's the slope. Now what is the point? Well, the point is when theta equals 0, right? So when theta equals 0, when theta equals 0, r is e to the 3 times 0, r is 1, right? So what is the point with polar coordinates, angle 0, radius 1? Well, that means x is, x and y are the following. X is r cosine theta, and y is r sine theta. So x, the radius is 1, and the cosine of 0 is 1, so this is 1, and this is 0, right? So that's it. We have the slope, which is 1/3, and the 2 points. So here's the equation. The equation is y minus 0 equals the slope times x minus 1. Right? So the hard part, again, is figuring out the slope. That's the challenging part. And just to finish it up, let's actually do the arc length and arc length problem. So either A or B. Let me think which one will be easier or harder to show. I think either way. I mean, remember, so this is easy. The setting up the integral is easy. The finding out the integral could be complicated, right? So let's start with A. So that's 27 second A. So arc length of r equals theta squared from 0 to √5. Let's change to the screen. So here's the arc length formula. So 0 to √5 of the derivative square and the original function square. Doesn't matter which one first, right? So the original function is theta, so that's theta squared squared. And the derivative is 2 theta, and we're squaring it. So this is the integral we need to do from 0 to √5. And this is theta to the 4th plus 4 theta squared. And here we can take one of the tests, so we can factor it. Okay, so we're done with setting up the integral. So now the hard part is to do the integral. We can write it like this. And this theta can come out because it's absolute value of theta, but between 0 and √5, it is positive. So that's theta times theta squared plus 4. And that's good because now I can do a u sub, right? Now I can set u to be theta squared plus 4. So then du is 2 theta d theta. So my integral becomes 1/2 of du square root of u. And let's change the parameters. When theta is 0, u is 4. And when theta is √5, u is 9. So it's from 4 to 9. Now we can iterate. The integral of u to the 1/2 is u to the 3/2 divided by 3/2. So that's multiplied by 2/3. From u equals 4 to u equals 9. Those go away. So this is 9 to the 3/2 over 3 minus 4 to 3/2 over 3. And I would leave it like this if this was on my exam. There's no need to simplify further, right? So here we were lucky. We were lucky that we could take this out and then we could do a u sub. But in general, these integrals can be complicated, right? We could get an integral that has a square root that we can't get rid of, right? So the part that you should concentrate on is at least be able to set up the integral that represents the arc length of the curve we want. Okay, so that's pretty much all the time we have. We didn't do any about getting the area, but you can check out the video from the last couple of classes, because we did plenty of those, right? Where we figured out the areas of polar regions. Mm-hmm.
Professor,
Yes.
are all the videos posted? Because I didn't see the 2 recent ones yesterday.
They should be there, right? Yeah. I even made a playlist that has all the videos. Mm-hmm. So someone asked, let's see who asked here. Matt, will this be updated to Canvas too? Yes. So the one where I just did, I mean, it just takes some time for it to process, right? So by this evening, it should be there too. So I start processing it as soon as the class is over, but it takes some time, right? I edit it. I usually remove all the unnecessary pauses, and make any type of adjustments that are needed, and then that takes some time, and then it takes forever to be uploaded to YouTube. But it should be there by, I don't know, like 7 p.m. or so today. Yes, the exam starts at 1, so in about an hour, you will be able to download the exam. Mm-hmm.
Professor, can you go back to 26B?
26B, sure. All right. Any more questions?
Yeah, Professor.
Yes.
Can you explain why dy dx equals dy dt over dx dt?
Sure. So when you have parametric equations, this is what you have. You have y, and so x is a function of t, and y is a function of t, right? And we're for some range of values between a and b, something like this, right? And then you want to find out dy dx, and the way we do it is in an indirect way. So instead of figuring out what is dy dx, what we try to do is we try to do the derivative of y with respect to t, right? So imagine, so whenever we have a graph, we think of y as a function of x. It's a function of x, and then also x is a function of t, right? So you can use the chain rule then, right? If you want to do the derivative of y with respect to t, and it's a composition of functions because y is a function of x and x is a function of t. So then because it's a composition of functions, so then what you can do is do the derivative of y with respect to x times, right, that's a chain rule, times the derivative of x with respect to t. Mm-hmm. And then from here, to figure out the one you want, you just divide by dx dt. So
Okay.
Mm-hmm. dy dx is dy dt divided by dx dt. And the nice thing is that it sort of feels like you cancel the dt's and that's it, right? But that's not true, because this is a one symbol, right? So that's one of the advantages of this Leibniz notation, that it seems like you can just cancel the differential t on the bottom and then you get what you want. And then that's the obvious reason. But it doesn't quite work like that. Mm-hmm.
Okay, thank you.
Mm-hmm. All right. Okay, guys, I'm going to stop it right here because I have to actually upload your test so that it's ready at 1. Put the file. Make sure you read the instructions as I was telling you. So before starting the test, make sure you read the instructions. It's not as short as we usually have because there's many things to be considered. So take the time to read the instructions. You have 24 hours, so there's really no excuse there. Okay, good luck everyone. Try your best, and I'll see you guys next week. All right.